So today's my topic on design and drawing of RC structure. So from this design and drawing of RC structure, so it is based on the storage structure. So storage structure is as a liquid storage structure. So here I have the water tank for the discussion of liquid storage structure. Okay. So from this I have discussed in the water tank. So first, general discussion about introduction about the water tank. So how to design and general in definition about the water tank. So storage tanks are built for storing water, liquid, petroleum products, and other similar liquids. So designed or crack-free structure to eliminate any kind of leakages. So mainly the storage structure, liquid storage structure should be designed as a crack-free structure to eliminate any kind of leakages. It does not go for the leakages. Always the liquid storage structures are designed in a working stress method. Okay. So design the permeability of concrete is directly proportional to the water cement ratio. Water cement ratio. Permeability of concrete is directly proportional to the water cement ratio. Cement content ranging from 330 kg per meter cube to 530 kg per meter cube is recommended in order to keep the shrinkage is low. So to make the maintain the shrinkage low in a water tank storage structures. Then water tank can be classified into broadly classified into two types. So one is based on the placement of the tank, and another one is based on the shape of the tank. So the placement, it means that where it was lying, whether it is kept over the ground or into the ground or elevated. So based on the placement where we locate the tank, so that comes under the category of based on the placement of tank. So based on the placement of the tank can be classified into three types. One is resting on ground, another one is underground, and the third one is elevated. Based on the shape of the tank can be classified into rectangular, circular, spherical, ends, and conical bottom shape. So these categories are fall into five types. So based on the shape, circular, rectangular, spherical, ends, and conical bottom. So each and every design are based on the working stress method. We can't go for the limit state design as the what the we design for the building. The same thing has not done in the water tank storage structure. So it should be a crack-free structure. It should not affected from any kind of the leakages. Okay. So then this is the resting on ground. How the tank can be rest on the ground means it is resting on the up the soil. Okay. So that is called as resting on ground. This is underground tank. Most of the houses are constructing with the underground tank. Then this one is the elevated tank. Then this is the circular. Then this one is rectangular. Then this is spherical. This one is the ends. Then conical bottom. So this type of tanks has been used in widely packaging. So the most economical tank for construction, more than less than the 3000 liter capacity of the tank, we can prefer with the rectangular tank. So it comes under the economic. When we go for the circular, it is over the economic. So it is possible for the circular tank is more preferable for supplying of municipal water. When it is a overhead, it totally it's an when comparing with the cost wise, this circular tank is most economical than the rectangular tank. While it is the less than 10,000 liter, we move with the rectangular tank itself. Okay. So circular tank resisting on the ground. So how it's resting on the ground and what are the steps has been included. So the tank has the tendency to increase the dia due to the hydrostatic pressure. The pressure which is created inside the water is called hydrostatic pressure. The tank has a tendency to increase the dia. How to increase the dia? So due to this pressure can increase the dia tendency to increase the diameter over the circle. Okay. Then increase in dia all along the height of the tank depends upon the nature of the joint at junction of the slab and wall. So it happen on the joint places, the junction of the slab and wall. So it happen in the places. So generally it can be classified into two types: the tank with a flexible base, the tank with rigid base. So how it is, we said that is a flexible base when it is a rigid base. So rigid base, it means that we provide a support. A flexible base, it means that we provide the column, that is wall and base are connected in a monolithic, so in a single joint, so that is called flexible. When we are providing the flow base at a part and we provide the wall at the different, so it means the rigid. Totally these are the two components. It's constructed in it's not having any joint or any relationship. It was constructed separately, it was constructed separately. So those two things are constructed separately when it is called as a rigid base. So flexible base is more preferable for the tank storage structure, and also rigid base in some conditions, some criteria has been, as per the IS codal preventions, the rigid base also practicing. Okay. So then when the joint, the base are flexible, when the condition, when joint at the base are flexible, the hydrostatic pressure induces the maximum increase in dia at base, no increase the dia at the bottom. While comparing when the hydrostatic pressure, when flexible joint is possible, when a hydrostatic pressure is acting on the fluid, that is a storage structure, the topper dia and bottom dia have the some deviation, because there is a no increase on the dia at the top, because all the forces are exerted on the bottom. So in the previous slide, I have shown the how the distribution of the pressure exerted on the wall, how it reacts. So maximum pressure at the bottom, this maximum pressure at the bottom, which will make the dia as longer. Okay, so this one is the thing. So when the joint at the base is rigid, the base does not move. So some condition, if it was constructed separately, wall constructed separately, then base constructed separately, there is no displacement, there is no movement, because the force acting, that is the hydrostatic pressure acting on a wall, is minimum when it is a rigid base. Okay. So design of circular tank, design of circular tank on a ground with a flexible base. So when it is a flexible base, so it will be like this, and we have this, take the torsion twisting movement as rho g h divided by 2, then AST is calculated by using this formula. Then maximum hoop tension in the wall developed at the base. So we can find out where the maximum hoop tension. So based on the hoop tension, we are going to design a water tank at what height it can be designed as a cantilever joint. The tensile forces T is computed by considering this is the tensile force T is computed by a tank as a cylindrical thin cylinder. Then this formula also used when the thickness of when the thickness is less than or equal to 225 mm, the steel placed at the center. This is the wall thickness. When the thickness is greater than 225 mm, at each faces, AST divided by 2 of the steel as hoop reinforcement is provided. So the stress in concrete is computed as, how the stress in the concrete is computed as. So stress in the concrete is computed as sigma c equal to T divided by AC plus M minus 1 modular ratio minus 1 into AST. Already we seen in the previous slide about this one. Okay, so this is okay. So if sigma c less than or equal to sigma c at where sigma cat is, which is equal to 0.27 root of FCK, then no crack appears in the concrete. So while designing, the thickness of the concrete wall can be estimated as T equal to 30H plus 50 mm, then where H in meters, then also distribution reinforcement in form of vertical bars are provided such that steel area required will be satisfied. As base slab is resting on ground, no bending stresses are induced. So hence the steel distributed at the bottom and the top is provided. While designing for the thickness of the concrete wall can be estimated as So that's the thing has been explained in the previous itself. So next, the problem circular tank resting on ground with a flexible base. So it's a model problem. So in a problem, the data will be given as, so design a circular water tank with a flexible connection. So some of the question it may given as a flexible condition and another part as a rigid condition. So when it is given as a flexible condition, so here it was given that the capacity of water tank as 4,000 liter. The tank resists on a firm level ground. Okay, it means on firm level ground it is resting on a ground that is called as firm level ground. The height of the tank, including the freeboard, is 200 mm. When the freeboard data is not given, we have to consider the freeboard as 150 mm to 300 mm. We have to assume the value from 150 mm to 300 mm. Then, including the freeboard, the height of the tank should not exceed to 3.5 meter. It means that the height of the tank which comes with the freeboard, the tank is open at the top, then use M20 grade of concrete, then Fe415 style has been used. Draw the suitable scale, plan at base, then cross section through the center of the tank. So these are the things we have to drawn in a, for this design. Okay. So move into the design procedure. So we have the step for finding the dimension. So it's a initiative one. So each and everything we have to find out the dimension. Then what is the shear force is acting on the structure, and what is the bending moment created due to this hydraulic pressure or force. And then after that we find out we have to satisfy all these conditions. Then we provide the minimum reinforcement detailing. So after that reinforcement detailing, we have to show that plan and cross section and everything. So dimension of the tank. So depth that is h, which is equal to height is 3.5 is given. When it is neglect with the freeboard, we get the value of 3.3 meter. Volume is 4,000 liters. So it is given in a liter. We can convert this in a meter cube, that divided by 1,000. We put, so then we get 400 meter cube. Then area of the tank divided by area of the tank, which is volume divided by height, that is 121 meter square is the area. Then dia of the tank is taken as 13 meter. Then thickness is assumed as a 160 meter. So this is the basic data has been included. Then design a vertical wall. So AST, minimum AST provided, then steel record for the more than the AST, then spacing between the bars, check for tensile stress when it is safe within the permissible limit. Okay, thank you.